I'd like to welcome everybody to today's webinar, New Products for Reducing Southeast Forest Disturbance Risk and Recovery Time. For today's webinar, if you have questions, we ask that you type them into the question and answer feature of Zoom. All you have to do is click on the little icon that says Q&A, and you'll be able to enter your question in there. And we ask that if you type into the chat window, please keep it relevant to today's webinar so that we're able to follow along and assist people if need be. Couple other things. One is if you're participating for today's continuing education credits, just want to remind you there's a satisfaction survey that we'll ask you to complete at the end of today's webinar, as well as a short quiz that you'll need to pass in order to get your continuing education credits. Upon completing that, you will receive directly from forestrywebinars.net through your email a certificate indicating that you've completed that process. And today I'm going to move on. I'm going to stop sharing my screen so that our presenters can share. We'll be hearing from Michael Gavazzi and Steve McNulty with the U.S. Forest Service on today's webinar. With that, I'm going to turn it over to you, Michael.
Great, thanks, Bob. I appreciate it. Yeah. Good morning, good afternoon, everyone. I'm Michael Gavazzi, coordinator for the USDA Southeast Climate Hub. Thanks for joining today. I'm going to give a brief introduction to the Climate Hubs, and then Dr. McNulty, ecologist and director of the Southeast Climate Hub, will talk about forest disturbance and tools to help producers remain resilient and productive. For nearly 30 years, USDA has been investing in research and technology to better understand the impacts that climate variability and change have on agriculture and natural resources, such as forests. There's now a critical need to operationalize this science by bringing knowledge, information, and tools to farmers, ranchers, forest landowners, other producers, as well as community and tribal government leaders. The establishment of the regional hubs for climate risk and adaptation and mitigation to climate change is providing localized research and technical support to address the impact of our changing climate. USDA Climate Hubs were established in 2014 by then Secretary Vilsack. They were established to improve the transfer of information, tools, and research findings to producers to enhance climate-informed decision-making and improve their resilience and productivity under the threat of climate change and climate variability. There are 10 regional climate hubs, 7 that are truly regional in nature, as you see, southeast, southwest, northwest, and on. And then there are 7 other smaller localized hubs that have a unique focus, and they're the California hub, the Caribbean hub in Puerto Rico, and the Northern Forest hubs in Michigan. The Southeast Hub covers 11 southeastern states, all the way along the coast from Virginia, all the way around through Louisiana, and then up through Arkansas, Tennessee, and Kentucky, and also the eastern portions, forested eastern portions of Texas and Oklahoma. One of the challenges we face in covering such a large geographic area containing highly diverse working land communities. To accomplish our mission in the Southeast, we've worked with federal, state, university, and private organizations to develop practical tools that land managers can use to increase their resilience to climate variability and climate change. Here you see just an example of a few of the tools, and Steve is going to incorporate those into his talk and talk about each of those a little bit more when it's his turn to take over, which is now. So, Steve McNulty, I will unshare my screen.
All right, Michael, thank you. All right, can you all see my screen now? I'm not sure, I can't tell if it's transferred or not.
We cannot, Steve.
Okay, Michael, you may need to, I've hit the share button, so I'll share it again.
So Steve, when you hit the share button, a window should pop up in which you can select your PowerPoint presentation.
Oh, I see. Okay.
You'll need to pick that and then hit share.
All righty. Can you
There
see
you
it now? All right.
Yep.
Thanks, Bob. All right, let's put this onto presentation mode. Okay, so you should see in front of you now a screen that says 3 important points. So as we go through today's talk, there's a couple of things that I think we need to be aware of. One is that we're going to be talking about the different types of disturbances and tools, but I think it's also important to understand what those disturbances are and how they're changing. So the first important point is that disturbance is part of the natural ecosystem, and it always will be. You know, this is something that hasn't been invented in the last 50 or 100 years. It's something that we've always had to deal with as foresters and in dealing with natural resources, and that will always be the case. However, there are many different types of disturbances that have increased over the past century, and I'm going to go through a few of those today. And finally, almost all disturbances are expected to increase moving forward. So a lot of the types of things that we're seeing now, we're at the very beginning of seeing shifts in those types of disturbances, and I'll go through some examples. The thing to remember, if you're planning to do a rotation that's 30 years or more, you really need to be aware of both the short-term disturbances and the long-term trends. These are different things. Short-term, and I'll go through both of what a short-term disturbance and a long-term trend actually is. This is a graph that kind of gives you perspective from a standpoint of the Southeast and of the whole United States of what kind of disturbances that we have. So if you start up on the upper left-hand corner there, droughts and heat waves are sort of universal across the US, but there's probably a disproportionate more of them in the Southeast. You would think they're more damaging in the West, but in terms of economic dollar loss, billions of dollars, the Southeast has a lot more valuable commodities in here, and so we see more damage from them. Winter storms, moving up to the central map, we have a lot of problems with winter storms. So it's not just hurricanes and those sorts of activities, but it's also the winter storms. New England and the East Coast has them, but as you know, in North Carolina, we have our share as well. Then, of course, in the upper right, we have tropical cyclones. These are hurricanes and other types of events that are from the Atlantic or from the Gulf area, and for that reason, we're also prone to those. Well, in addition to the heat and the drought, we also have flooding. So we get the best of both of those worlds, if you will. Texas is probably the epicenter for both flooding and for droughts, which seems ironic, but that's the way it turns out. Wildfire in the Southeast is something that we have, but it's not nearly as problematic as it is in the West. And we see this graph here, particularly of California, because of all the valuable real estate and other types of commodities there, that wildfires in the West are more of a problem than in the East. And then finally, local severe storms. So in the Raleigh area yesterday, we had severe storms for about 6 hours. And this morning we had some damage. There was nothing to it other than a local front coming through. If you combine all of them and you say, well, what's the most value or what's the most damaging and causes the most economic loss within a region, you can get an idea that severe storms through a good share of the United States are the primary cause of most of the damage. But in some areas, winter storms in the Northeast, wildfires in the West, and tropical storms in Florida are other problems. And then there's an area in the Midwest where it's drought. But the entire region is impacted by different types of disturbances. Let's talk about drought. Drought is one of the ones that's most frequently talked about in the Southeast, and it does a lot of economic damage and forestry damage. One thing we should remember when we talk about drought and we talk about climate and weather is that there's a difference between climate and weather. Mark Twain, 150 years ago or so, said, climate is what we expect, weather is what we get. And that's absolutely true. So when we talk about these changes, we shouldn't confuse the two. I'll give you an example. Here's one that talks about the brutal heat wave is about to scorch many parts of the country for weeks. That's weather. It's the summer. This one I pulled off on July 10th. It's going to be 120 degrees some areas that weekend, if you recall. That's weather. You know, when you have a period of really hot weather when you expect it or cold weather when you expect it. That's just weather. If we look at drought in association to that, you can see that it moves around a lot. Here's just some images showing how drought changes over space and time. First one is from 2010, showing sort of low-level drought, but not a lot of drought anywhere in the country. Move up to the next year, and we had, if you recall, a really bad drought in Georgia and an extremely bad drought in Texas in 2011. By 2012, the drought had subsided to a certain extent in Texas, moved up to the Midwest, but there was still that very bad drought in Georgia. Then by 2014, we were talking about the droughts in California, sort of that continuous drought in Texas. If you remember from the previous slides, that just is there a lot. 2016, back to drought in Georgia and parts of the Southeast and in California and in the Northeast. We get to the most current map, and again, we have drought widespread, although not severe in most areas, except for maybe parts of the Great Plains. And a lot of the drought that we had early on in the Southeast isn't showing up on this US Drought Monitor. So one of the things that are changing over time is that we're having earlier drying. So in the spring, there's earlier greening. Whenever you have greening, you're having the leaves come out and they're taking more of the water out of the soil. And so if all else is the same, if you have an earlier greening, you're going to have drier soils, which can lead to periodically more droughts. Now, the tree response to drought can be highly variable. And as I talk about these different tools that we have to manage disturbances, sometimes you don't need a tool at all. Sometimes the knowledge we have is sufficient and you don't need anything special. We've been studying the impacts on forests on drought for many, many decades. And so here's an example of where we just can base our actions on that type of knowledge. So there's 4% potential types of drought outcomes, and it depends on the type of drought, the severity of drought, and where you are. You can have a reduction in productivity followed by forest recovery. That's probably the most common. You won't have a really good year for basal area growth, but you'll still have the trees coming back the next year. You can have the potential for reduction in productivity and no recovery, i.e. forest mortality, like occurred during the severe drought down in Texas in 2012. You're gonna have no change in productivity. So if it's not a very severe drought, or depending on where you are in the landscape, you may not notice any change at all. And it's even possible that when you have a drought, you'll see increased productivity. And so the tool that I'm trying to get across here is just knowing where you are on the landscape and knowing what you should be doing in response to that landscape. So let me give you an example. If you're on the ridgetop, the mid slope, the bottom slope, or the flooded portion of a landscape, a drought will affect the same amount of area of precipitation may occur across this area, but you're going to have a very different response to it from an ecosystem standpoint. If you're in an area where you have a reduction in productivity followed by recovery, that may be something like the mid-slope, where you're having some precipitation that enters the landscape, and then as it drains down, you still have some moisture coming out of the soil, and so you may have a reduction in productivity, but it's not as much as it would be without a drought. So the types of tools you use to do that would be a pre-commercial or a pre-drought thinning and also a pre-drought controlled burns. They reduce the amount of leaf area in these areas. Anytime you reduce the amount of leaf area, then you reduce the amount of potential drought stress. You may be on a ridgetop. If you're on the ridgetop, you may have loss of productivity. You may have also tree mortality. And the options you can do then is, again, pre-drought thinning, pre-drought controlled burn. In the longer term, if drought becomes more of a constant risk in that area, you can do changes in species selection. Certain species, the hardwoods can be more drought tolerant than some of the deciduous trees. And within both hardwood and deciduous, some species are more drought tolerant. I'll talk about those in a minute. You may also want to harvest these areas shortly after a drought, or if you're entering into a drought, to maintain the quality of the wood. Here's some examples of just some drought tolerant tree species. Some of the carious species and ash And those type species, a lot of the pinus species, particularly longleaf pine, is a very drought tolerant species compared to something like Pinus taeta. Some of the loblolly pine species. So as we go into more drought prone periods, one of the options that forest managers are looking at are shifting in tree species. There's been some recent work that has been done on this. One is a paper, or is a publication by Vose et al. That came out last December 2019, and it's the effects of drought on forests and rangelands in the United States, translating science into management responses. This has chapters on all the different regions of the United States, including one that I wrote for the southeastern US. So I think this is a really good resource, a good tool to learn more about how drought will impact forests, not only from a commercial standpoint, but also from a biodiversity and hydrologic and all the ways that drought can impact these ecosystems. So one of the things that you need to understand about when you're talking about drought and changing climate in general is the El Nino and La Nina, these ENSO events, these very natural, have always occurred types of cycles in the temperature of water in the Pacific Ocean, primarily off the south coast of South America. And you can see from this graph that I have here that from 1950 to, that goes from about 2015, that there are both El Nino and La Nina events that are occurring constantly. And for the Southeast, what that means, if we have a El Nino event from a temperature standpoint, it means we're going to have a cool winter period from November to March. And for a La Nina, it's the opposite. We're going to have a warm winter period. From a precipitation standpoint, if we have a El Nino period, we're also going to have a wet period in the Southeast and a La Nina, a warm period in the region. So it means if you have El Nino, it's going to be cool and wet. If you have a La Nina, it's going to be warm and dry throughout the winter months. And this can have impacts as far as harvesting and getting into wet areas to do logging. It also has impacts for the spring. If it's going to be a warm, dry spring, your opportunities to be doing controlled burnings or to be planting species may be limited in those years. So it's important to understand what type of pattern we're going into. And we generally have several months of advance notice by looking at ocean currents to better understand that. However, with climate change, one of the things we're finding is that these La Nina and El Nino patterns may be shifting as far as their severity and frequency. This is a paper that appeared in the journal Nature about 5 years ago that talks about how greenhouse gas effects, CO2 and methane, are impacting the ENSO occurrence. So as we start talking about some of the climate change and what disturbances those are having in the region, it's important to understand how weather shifts into climate change. On this graph that I have on the screen, if you look at the lower left area, that's the length is in days and the amount of variability is low. That's weather. So that's not to say that there's no variability in weather, but it's to say that weather generally is always variable. It's hot one day, it's cold the next, wet and dry, those kinds of conditions. If you go up on the scale, on the y-axis, on years, and you have low variability, that's climate. That's what you would expect to see over the winter or the spring. Low variability, that's just natural variability in that particular variable. As you move along the x-axis to the right and you shift toward more variability, that's when in the short term you're talking about climate change variability or variability in weather that is becoming more extreme. And on the longer term, you're talking about changes in climate trend. So shifts in what used to be one type of weather is now becoming a completely different kind of weather. And so we'll talk about some examples of these and the tools that we use to address them now. So let me give you some example of how this weather turns into climate and how it's important for management. Here's a map that, again, is not too old. I think it's from a couple weeks ago. And it was an article that basically said that we're going to break 40 possible records on this particular day. Well, that's a heat wave, right? We always have heat waves. That's not that unusual. Now, making 40 of them, yeah, it's a widespread heat wave. But again, still in the area of weather. When you start to get into the extreme events of a heat wave, then that starts to shift into this is beyond the norm. And it's important to understand that this isn't the condition normal, but this is something that we shouldn't expect very often. And because of that, it can have a very high impact from that occurrence. Here's an example for Russia that came in about 2 weeks ago, and it reached over 100 degrees Fahrenheit up in the Arctic Circle, very far north in Russia, where obviously this doesn't happen. That's still a single isolated event, but it's an unprecedented isolated event by quite a bit. From a management standpoint, and the type of tool that you can use to manage your forest with that knowledge is a simple graph. In this case, on the y-axis, the probability of occurrence increases on the y-axis, and this is one for temperature, so it goes on the x-axis from cold to average to hot. And the bubble that we have in the middle, the taller, kind of more compact bubble, that's our current climate. And as we begin to go through a period of shifting climate, and we're in it now, that we're likely to see more of these extremes like they showed for Russia, with this bubble kind of shifting to the right. So we're still going to have some extreme cold weather, as the graph shows on the left. We'll still have a lot of average weather, but we'll see more and more of this hot weather and more of this record weather, and in this case temperature, but it includes other types of events as well. However, that's not universal. This is a map that shows from 1895 to 2018, and it shows temperature differences over that time period. The darker reds are showing areas where it's gotten hotter. If you look at this, you'll see that parts of Mississippi and Alabama have actually cooled down. So it's actually cooled over this time period. North Carolina has seen some increase in temperature, but not nearly as much as many other parts of the country. So to date, the Southeast really hasn't experienced as much of the heating as many other parts of the country have. But that's likely to change, but that will change in the future. And what we're seeing is more of these record changes occurring across the entire globe, and that's an indicator of how we're shifting. Now, if you remember, if this is a global temperature, in the north when it's summer, in the south it's winter, and vice versa. So in any particular month, you can have the warmest month ever recorded. So in this case, this is from 2016. January was the warmest month ever recorded, until we got to February of 2016. Then that became the warmest month ever recorded. And then we got to July of 2019, and then that became the warmest month ever recorded. And if you look at this map, again, looking at the Southeast, it wasn't particularly warm that month. And in some places, like Louisiana, that was actually a cool month, cooler than normal. So you can't always go by what you're seeing locally as far as what global patterns are doing, but global patterns give you an idea of the direction we're heading. Until we finally get to May of this year, and now this May was a record warm month. And now 2020, at the rate we're going, is going to be the warmest year ever recorded. And as it turns out, the 10 hottest years ever recorded from 1881 to present all occurred in the 21st century. So over the course of the last 20 years. So these changes in temperature and precipitation are going to have a lot of impacts on disturbances, including wildfires. If you remember the earlier graph, we didn't have a lot of impacts in the Southeast historically, but that will probably be changing as well. Here's a graph that shows the amount of acreage burned from wildfires over time, going back to 1926. You can see that we had a huge increase in wildfires until about the 1950s, when we really started to actively suppress them. We got better road networks. We did a lot of logging. We were doing a lot of removal of the fuels that would cause those wildfires. And for a long time, the amount of wildfires were pretty stable, pretty low. However, the amount of wildfires has been recently increasing for several reasons. One of the reasons is that we haven't been doing as much logging, and the wildfire fuels are beginning to increase. We've been doing a lot of fire suppression outside of logging, and so that's not been a problem for it. But the other issue that's caused these fires to start to increase again beyond the amount of fuel loads that are building up are changes again, going back to this graph, in the amount of hot and record heat weather. So there's a paper that was done a few years, well, about 15 years back, that basically said when it gets hot and dry, you're more likely to have fires. Now that doesn't seem too surprising, but no one ever looked at it. And once they did, Easterling wrote this paper and he said, well, if you have hot, dry springs, you're going to have a lot more wildfires. And you start looking at places like California that has a record number of wildfires, and you see that that's what they're doing. From 1900 through about the 1960s, 1970s, not too much of a change, a little bit of an increase in the January through October temperature. But since about 1980 or so, and certainly most frequently, you're seeing these real spikes in temperature, which are sparking more and more of these wildfires. As far as the types of tools, again, it gets back to the same things you would do during a drought. You would do thinning, pre-commercial thinning, controlled burning, those types of activities that would reduce wildfire risk. And species selection is another one of those where there are certain species like, again, longleaf pine, which is was largely removed and now is starting to make a comeback because it is more drought and also fire resistant as far as management activities to try to control the amount of damage from wildfire incidents. The next thing I want to touch on are outbreaks of southern pine beetle. Southern pine beetle is the most damaging beetle we have in the southeast. And again, like wildfires, that we used to see a big spike in it. This is a graph from 1960 to 2015. And you can see there's a big period in the 70s and intermittently through the 80s and 90s, even early 2000, where we were seeing a lot of beetle activity. But for the last 20 years or so, we haven't really seen much until we got to the year 2017. And in 2017, we started to see all these outbreak areas. And these outbreaks, a lot of them occurred in areas that were National Forest Service system lands because we're not logging those areas. And one of the factors in southern pine beetle outbreak is overstocked stand, because when you get overstocked stands, the trees start to dry out, they get water stress, they can't produce the resins, and the beetles attack. So one of the tools that we developed to address this was we developed a tool called SPOM, Southern Pine Beetle Outbreak Model. And this is a graph that shows the predicted values in 2019 versus the observed. And so we predicted this using previous year's spot data, a projection of the climate for that next summer, and produced this map in March, I believe, of 2019. And then this is from January of 2020, where the beetles actually occurred. And there was a very good correlation to where we predicted the beetles would be and where they actually were found. So we're using this model again this year. This is the 2020 Southern Pine Beetle Outbreak Model. And it's very important to have these types of models because it gives you an idea of where to look for the beetles to occur. If you have to look all over the area, you're spread pretty thin. If you know that, for example, Alabama, maybe parts of the Northeast Georgia and along the Georgia-South Carolina line, maybe part of Florida this year, maybe areas to really focus on watching for the beetles. You can get in there early, cut down the trees while the beetles are still fairly localized and stop the outbreak from spreading. So if you compare that to the 2019 beetle year, you can see there's much less activity predicted for this year. So there's a lot of different mitigation management you can do. As I said, you basically, the main one is to cut down the trees and get rid of them, but also monitor with traps to use that as a tool to find out where the beetles are occurring and to be aware of that so that you're monitoring for those very closely. Okay, so one thing we did is we wanted to look at areas and how that might change going forward. And so we did some climate scenarios with these, looking at a 2-degree increase in temperature and a 20% decrease in precip. This is the most common scenario for the Southeast of how our climate will change over the next 20 to 30 years, particularly with precipitation and longer term on temperature. And what we found is that we're going to have more areas that have enhanced, marginal and enhanced, and moderate outbreak activity from the beetles. And And this shouldn't be very surprising because, again, the beetles like these dry trees. When the trees are dried out, they don't have the resins. They can't push the beetles out as the beetles try to colonize those trees. So the beetles are much more successful. So as the trees become drier, we're more likely to see problems in beetle outbreaks. Let me talk about storms next. We've talked a lot about drought, and the flip side of that is that we're also having more extreme rain events, which seems counterintuitive if you're having more drought. But from 1910 to 2018, the amount of extreme storms has gone from about 6% up to about 13%, which is about a threefold or 3 times increase in these 1 day, 2 inch more rain events. And those have a lot of impact from a standpoint of flooding and the need for larger culverts and types of harvesting you can do as far as exposed soil. In the Southeast, we've seen about a 27% increase in the amount of very heavy precipitation from 1895 to 2016. That's been a pretty significant shift. In the Northeast, it's even been worse. They've almost seen a 71% increase in the amount of extreme storms. Knowing how climate is changing in the region allows us lead time on developing tools and management strategies to address these kinds of changes. When it comes to extreme storm events from storm surge like hurricanes, they range from tropical storms, fairly mild, all the way up to these catastrophic storms. The catastrophic storms can have storm surges that can exceed 20 feet or more. So when you get a storm surge like that, it pushes far inland and you have problems with saltwater intrusion on your forest soils. If that persists there, then you can have problems with mortality and long-term productivity of those lands. So what we've done is we've been developing a series of landowner guides with the Climate Hub over the last 1.5 years, and these are now online. This first one is Hurricane Preparation and Recovery in the Southeast for Pine Forest, the landowner's guide. So if you just Google Pine Forest Hub Hurricane, you'll come across this. It's about a 40-page guide that tells you everything from how you would manage your stands to reduce the impact of a hurricane to how you could get those back into production as quickly as possible after a hurricane with minimizing the amount of economic loss. Another product that we've developed is one that's a coastal salt salinization and adaptation guide. Again, also associated with not only hurricanes, which can cause saltwater intrusion on landscapes, but also for sea level rise. So if you've gone along the coast, if you work on the coastal plain, you'll see these areas where we have what we call ghost forests. So these are mature forests that at one point were standing timber. And because of either sea level rise or because of saltwater intrusion, that water in those stands has risen and the salinity content is such that it's killed the trees and they're no longer able to support future rotations. So some of that can be corrected, particularly if it has to do with a storm surge. And so this guide is designed to help the forest manager to evaluate what kind of situation they have, whether it's a short-term event caused by a hurricane or a longer-term event that might be sea level rise or both, and then also what type of options they have as far as what species are most adapted to more saline soils and what they can do to try to ameliorate or reduce that salinity level. We developed these manuals not only for forests, but also for agricultural crops and also for grazing areas along the coast. All right, I'm going to just say a word or two about nursery production. Nursery production is another area that can be impacted by these different types of disturbances. There's a lot of good information out there about nursery production that you can utilize. The warmer temperatures and the longer periods without rain are going to shift again what types of species should be planted out there, what types of genetic varieties can be planted out there, the need to irrigate these trees in the early stages, and when these different species can be planted. And so there's a tool out there that's called the seed lot selection tool. It was developed in the Pacific Northwest, and it's being expanded for more species in the eastern and the southeastern area. But you can go online to this website, you can pull it up, and it will give you a geographic information about the location and what kind of species you're interested in, and then what sort of varieties of genetic stock would be most appropriate for that particular area. So you can also include climate and climate scenarios. You know, if you're thinking about planting a forest now, it's not going to be like a cornfield where it grows in a year. You're looking at something that's got at least a 30-year rotation length. And if you're in the Northeast, you're looking at a 100-year rotation length in many cases. So you have to think pretty far ahead in order to make sure that the trees you're planting now or the forest you're growing now are going to be viable and productive by the time that you want to harvest them. And the reason for this is because the temperature is increasing. We've talked about this before, but it's important to understand how it's increasing and where it's increasing. As you remember, that graph I showed before showed it's not really increasing much in the southeast yet, but all the models suggest that that is changing now, and it'll continue to change in the future. So right now we're seeing climate change. The temperature isn't that much, but we're seeing it in many other ways. And we're also starting to see the impacts of the temperature rise. There's a great tool that can help you to look at what species are available for addressing shifts in tree species. This one is, it's called Tree Atlas. It was originally developed in the Northern Research Station. And it talks all about the different tree species and their, how well we understand what drives those species. So in this example, American beech, we have high confidence. Something like net-all oak, we have very low confidence in understanding. But it allows you, particularly for the high quality or the high understanding trees, to predict how those species would shift over time. And this is just a map to show example. FIA data is on the left side there. And then Little's range map is the blue line. And it shows under different scenarios how those species shifts may occur in the coming decades. And in some cases, they're fairly significant shifts. I believe this one is for loblolly pine. And you can see the importance value moving up into Kentucky and even Illinois and Indiana. One important tool that we're working on now, or we want to start working on, is the Silvix of North America. This is probably the most important tool that we have as ecologists and foresters, because it includes hundreds of species across the United States and parts of Canada. That tell us how we should manage these trees. So here's just a page out of it showing ponderosa pine with its native habitat and other information, including the type of climate it likes, soils, associated forest cover, the life history, all really good stuff. Unfortunately, this document is about 30 years old. It was last produced in 1990, and a lot of the information going into it was from the 1980s. So it's woefully out of date in many ways. Here's an example of the current distribution map from 2019 on the top, and the predicted distribution map of 2050 for black spruce. So in 2019, we show a lot of it in Minnesota, Wisconsin, Maine. By 2050, which is only 30 years from now, it's going to be pretty much gone from those areas. And if you look at the range map on the left from 1965, it shows that it reached all the way down into central Ohio and those areas. So you can see that this is a tool that needs to be updated, and we're working on trying to do that. A couple more things I want to just point out as we close out this and open it up for question is a tool called TACAMO. You may have heard of this. It stands for a template for assessing climate change impacts and management options. It's an online tool that was developed in conjunction with the Region 8, the southern region of the National Forest System, and the U.S. Forest Service Research and Development Group, and also the East and West Threat Assessment Centers. And the tool is designed that you put in your geographic location, the type of information you're interested in understanding, whether it's biodiversity or recreation, productivity, all types of different activities. And it will tell you what the literature now says about what kind of stressors there could be for that particular area, for that area of interest. And then it gives you adaptation options on how to address that particular problem. And it generates a report that you can use to help guide the decisions you're making. So that's a tool I would recommend. Again, this just gives a little bit of an overview of it, what it does. It searches the peer review literature to give you the information that you need if you're a natural resource land manager. And this just gives you an idea of the types of areas that it works on or that you could be interested in: recreation, veg management, water resources, invasive species, a whole list of those that are covered within the TACAMO tool. And it's constantly being updated. There are 2 full-time people that do nothing other than comb the literature to update this the tool itself. So I'm going to close with this this picture, and this is a picture of my great uncle Bill Liebenthal, and he, like me, was a Forest Service employee. He was the forest supervisor of the Colville National Forest in Washington back 60 years ago, 50 years ago. And I brought it up because as a forest supervisor, he was dealing with a lot of the same issues we are today, disturbances. And this is an article that I guess they posted in the paper that said "Conservation for a Better Tomorrow." And it was a public meeting where they were taking in public comments and public thought about what the issues were and how the National Forest could address those issues. So, you know, when I talk about disturbances and the types of things we're seeing today and climate change, climate variability, well, they had climate change then. It wasn't anything like it is today, but they had other stressors. You know, they had DDT and all kinds of other things they were trying to wrestle with, and they overcame them. And I think that's the kind of the lesson of hope out of all of this, is that there's a lot of things that we don't talk about anymore. We don't talk about acid rain anymore because we got rid of it pretty much. We use scrubbers with sulfur and nitrogen scrubbers, and we got rid of the acid rain problem. We got rid of the DDT problem. When we stopped using that, the eagles came back. And, you know, there's just this whole long list of things that at one time were big problems. And right now, climate change, climate variability, these types of disturbances are big problems. But if we decide to make an effort at it, it's nothing that we can't handle the way we've handled everything else. And in the meantime, there are a lot of tools out there that will help you to address these issues and prepare for them, not only now, but in the years to come. So with that, Bob, I'm going to close out and turn it back to you.
All right, Steve, thank you very much to you and Michael. At this time, folks, we are going to go into our Q&A session. If you have a question for Steve or Michael, please click on the Q&A feature of Zoom and type your question in there. We do have 3 questions at this time. The first question is from Carl, and he's wondering, where do tornadoes fit into the disturbance table?
Yeah, Michael, don't turn off your speaker there, Michael. Keep that on. I'm going to fling some of these your way, so you're not out of the woods yet. That's a good question. Tornadoes are an important component. You know, they're very localized, but where they occur, they're highly destructive. If you recall, and I guess I could bring that back up if I wanted to share my screen again, where the tornadoes are actually occurring all through the United States, even in New England, but the primary area is in what they call Tornado Alley. This area in the central United States where the cold weather and the warm currents are meeting. And on this graph here, it would be the local severe storms, this one in the lower right. So this Texas going up through there where you see this dark patch, that's Tornado Alley, and that's one of the principal disturbances within that area. But as we know, we can see those anywhere. From a total economic dollar impact, if I think it's the next one down, if I can go down. Yeah. Severe storms, that's what we're talking about. That's not tropical storms. These are severe storms. So you can see they're the #1 issue as far as total damage in the United States for many, many states. Now, these are total dollar loss. These aren't just forestry or natural resource dollar loss, but so this would include property destruction, and that's what makes this so widespread.
Okay, next question. How does loblolly decline syndrome relate to climate change?
Well, there's a lot of different types. I mean, there's oak decline, there's loblolly decline syndrome, and a lot of these are fairly complex issues. It's not any individual stressor that can cause this, decline, but it's a combination of stressors. And often that's what we're seeing with a lot of the disturbances that are occurring out there. And I think the southern pine beetle was a really good example of that. So when you have a drought that occurs, you dry the trees out, and that doesn't necessarily kill the tree. But as you start to dry the tree out more and more, it maybe produces less resin. As it produces less resin, it may become more susceptible to secondary pathogens like the southern pine beetle. And so a combination of that, drought and beetles and temperature and other factors in a lot of instances are combining where any one particular stressor wouldn't cause the damage. And I think the loblolly pine issue is one of those.
Okay, here's one from Sandra. At about 1:39, you mentioned the name again of you mentioned a publication. Could you tell the name of that publication again?
At 1:39. Okay, I think that was it. Takimo. Does that sound familiar?
I think it was right before.
TACCIMO.
Yes, or was there another one right before that?
Let me see if I can hop out of here and jump down to where that would be. I don't have my slides timed to the minute. I apologize for that.
Well, no, I gave you that time frame so you at least give you a rough idea where you might.
Yeah, no, I was just kidding about. Yeah. There's a couple of them. It may have been the Silvics of North America, which is sort of the Bible of forestry for the United States. That may be what it was, and that's what we're trying to update now. It's going to be a monumentous task. There were hundreds of individuals involved in the last one, and there'll probably be more than that for this one. The other one it would have been the Climate Tree Atlas. And if you search for Silvics of North America or the Climate Tree Atlas, that's probably the one you're thinking of.
Okay. Sam is wondering, will the USDA develop and better publicize an easily accessible, comprehensive tool for anticipating short and long-term climate adaptive management practice needs options?
Yes, it will. Again, getting back to things are sometimes a little complicated. Climate is one of those. If you have increased temperature, but you have increased precipitation, you may not see some stresses. And so one of the challenges is to look at all of these types of impacts simultaneously. So to do that is a complicated task. I would encourage you to look at the tool called Takimo. That is not necessarily just a tool that compiles all that, but it does compile all the literature on that. So depending on where you are, it will tell you what information, what publications have been produced for that specific area on that specific site, and what adaptation has been found for that. Aside from a tool like a bibliographic search like Takimo, you really need to look at things like modeling. And there's some really good models out there as well that have been well validated, so we know that they work in reality, kind of like the southern pine beetle model. We know that actually works because we've tested it, predicted things, and then tested against the validation data that we later acquired for it. One of those tools in the Southeast is something called WASI, WASSI, and this is a hydrologic tool. It runs at a 12-digit watershed scale, hydrologic unit watershed scale, which is a very fine resolution. Give you an idea, there would be about 10 of these watersheds per county. And it runs at a monthly time step, and it runs for the whole United States. So you can look at historic data, you can look at climate change projections. It'll tell you how water yield will likely change for your particular watershed over time. And so that's very small scale. And that's a type of information that as a land manager you need to get down from these really broad pictures, you know, the average global temperature is changing by X amount. Well, that gives you an indication of the direction we're going, but it doesn't help you, as we've seen from the southeast, where we've seen temperature increases, temperature decreases. You need to get much finer than that. So there are tools that are being developed out there that get to a much finer scale. And one place that you could look for those is another site to Google is something called Toolshed, TOOLSHED. And this is a product we did in conjunction with the NRCS, Natural Resource Conservation Service. And it's a clearinghouse where you can look for, again, your area of interest, if it's forestry and recreation or forestry and timber management, your specific location, and it searches the types of tools that are out there to help you better understand what those impacts and adaptation measures are. So I would suggest doing a Google on the word toolshed, NRCS, and climate probably would be a good word to put in there as well. And you'll come across this, and you can just do some keyword searches to go through and then find, I think there's 180 different tools in there. So it's a major source of information.
All right, next question is from Tyler. You mentioned the influence of El Nino and La Nina influencing winter month temperatures and precipitation. Is this influence expected to move north over time? And will the Northeast experience similar climatic events?
Yeah, that's a really good question. If you look at this, here are the graphs on temperature and precip. Temperature, you already see some implications on what this means from the El Nino and La Nina events. If you look at the far sort of northeast area, you'll see a little bit on temperature, but not that much. If you look at the precip, you hardly see anything at all. So the precip is very definitely a kind of a southern tier, more of a coastal tier issue all across the United States, where it hasn't really reached that far north from a precip. But from a temperature standpoint, it already affects it. So if you're up in Wisconsin, or you can expect warmer winters with a La Nina. However, if you just go, you look at that transition there, you get up into northern Wisconsin, Minnesota, those areas, and you're actually seeing colder winters with La Nina. So in many regards, it's already there. As we see climate change, and this is what one of the things this paper talked about, this ENSO paper, was that we are seeing shifts in how the ENSO events are occurring with climate change. So it's very possible that we'll see some shifts, maybe stronger or less strong under climate change, with where these El Ninos and La Nina impacts are affecting certain areas.
So thank you. Next question is from Sam. He's wondering, might public notices to land managers of potential La Nina, other easily predicted events, and recommended management actions be developed?
Yes, the best place to find out about the ENSO events is through NOAA. NOAA updates their ENSO forecast. I don't know if it's monthly, but it's on a pretty regular basis. And they project out, if it's a very strong impact, they'll know 6 months out or sometimes even longer how these are going to occur. So I would suggest staying in touch with the if you're interested in property owner, knowing that you're going to have a cold, wet winter, depending on where you are, if it's an area where we have ice storm damage across the region, that may increase the risk of that. Or, if it's going to be a cold, wet winter, it means you may not be able to go log some of these wetter areas where if it's a warmer winter or a drier winter, you may be able to get in there. So from a standpoint of harvesting and planting for harvest, or from controlled burns in the spring or planting in the spring, or any other types of management activity, these are all considerations to keep in mind. As far as the types of, if there's a place where they compile all this information, for that I would suggest, again, there's the tools like Tacoma give you a lot of information about things like El Nino, La Nina, what the adaptation measures are for addressing those. So that, again, I'd put you back to that particular tool.
Okay, thank you. Question from Jerry. Jerry's wondering, how do I convince a landowner about climate change hysteria, and that's the landowner's words, not Jerry's, when they ask me to simply explain the ice ages and the warming following, and what could or will man be able to do to prevent them from reoccurring?
Yeah, I mean, that's a whole lecture in and of itself. I mean, the ice ages happen, but there are reasons they happen. They just don't happen randomly. In the ice age, we know based on ice core data that there were changes in the CO2 concentration at that point. And we know that change had to do with potential changes in the sunspot. So as sunspot activity increases, solar radiation increases. As it decreases, you have less solar radiation coming in. When solar radiation is less, you have less energy in the earth, and all kinds of things happen. You get more ice and it reflects more sunlight. There's a lot of complicated reasons for it, but the cab driver answer, the answer that I would tell a landowner is, when the ice age happens, it happens for a reason. When we know what those reasons are. Right now we're seeing change happening, and it's also happening for a reason. But the only factor that's been changing since we've seen this dramatic shift in climate has been CO2. And the only change in that has been emissions of CO2. So in ice ages, we see changes, but they happen over thousands of years, right? We see this slow shift from cold back to warm and then back to cold. That's all very natural. But what we're seeing now is a very unnatural phenomenon, because it's happening not over the course of thousands of years, but literally over the course of decades. And that's the problem. If we had 1,000 years to prepare for this, it'd be no big deal. We would adjust, but because it's happening so rapidly, we don't have time to adjust to it. And that's what's causing the hysteria.
Okay, we have one more question, and that's from Steve. And Steve's wondering, as climate change happens, what effects does warming have on recommended periods for planting seedlings in the Southeast?
Yeah, that's a really important question. Everything from when do you plant them? If we're seeing changes in the springtime temperatures, if it's getting warmer and drier faster, well, then that means you have less period where you have this optimal growing condition for the seedlings to get established before we hit these really hot, dry periods. So if you're going to combat that, you may be shifting earlier in the year to plant the seedlings. You may be changing your genetic stock, going with something that's more drought tolerant. You may be changing your species. So you may be going from loblolly pine to something like a longleaf pine, which again is more drought tolerant. So there are tools you can use. You may go from a higher density to a lower density stocking level, because when you go low density, then you have more water available for the trees that are there as they grow and mature, and also reductions in wildfire potential. So there are a lot of things that can be done. We just have to be aware of them, and that's why it's so important to understand what's going on and how it's changing. Not that we should be frightened of it or just throw our hands up or hide from it or ignore it, but acknowledge that it's occurring, and also understand, as my great uncle did, that there's a lot of things that we can do in order to adapt to these changes. We just have to stop ignoring it and face the reality that we're in a changing time and address it like we would anything else.
All right, it is 2 o'clock. It is time to wrap up our webinar. I want to thank Steve and Michael for taking the time to pull this information together and share it with us. Thank you guys very much. Folks, the webinar is being recorded, and the recording will be available on forestrywebinars.net, where you can also get a copy of today's presentation. And with that, that brings us to the end of today's webinar. Thank you all.
Thanks, Bob.